In our next section, we're going to begin discussing Cisco ACI programmability. So this is going to be a shorter module. Our agenda is pretty short and sweet. We're going to talk about the ACI API REST API, which is a bit redundant, and I'll correct that before I print the PDF, these slides and include them. And then we're also going to talk about the ACI toolkit. So let's talk about the very redundant ACI API REST API, which should really just be the ACI REST API. So Cisco ACI was really designed around open APIs and open source programming. We have this concept of object-oriented code. A very comprehensive access is given us to the underlying information model. We call this the management information model or management information tree of the model. And we have consistent object naming that's directly mapped to the URL or URI, as we just really finished discussing when we discussed REST in the last module. We support object, subtree, and also class level queries. We do support RESTful calls over HTTP or HTTPS, but of course HTTPS is what, as we mentioned, we should always use. We have the ability to query and get data, send and get in both JSON and XML carrying that serial data. We have a unified approach that automatically delegates requests to the corresponding components. We do have a transactional methodology as well as the single management entity, but fully independent components, meaning we're going to be making a call to a single controller or redundant controllers in case one is down, but we have fully independent components to this, right? So all of the switches are independent components, but we just make the call to the controller and it distributes all of the functions as needed. And we have that abstracted from us. And in fact, actually, let me go back, and we are not only making this is what we would call a northbound API. You might even see it sometimes written as NB API. So the APIC has a northbound RESTful API. It also has a native Python SDK, as I mentioned earlier. So this is what programs, whether it's a cloud management platform or CMP, like Clicker or UCS Director or vRealize Orchestrator, or whatever our northbound API is, or just a regular program, just anything that we want to use, we can call this northbound API to the APIC controller, and then it has its southbound APIs that it deals with Cisco-enabled fabric devices, the switches, and so for instance, Cisco AVS, OVS, and even Microsoft Hyper-V, it deals with from a southbound API perspective using the protocol OpFlex. And then for layer 4 through 7 managed service devices versus unmanaged, we have southbound RESTful API, or actually native Python API access, I guess I should rather say, to those devices like F5, Avinet, Citrix, SourceFire. Actually, Avinet's a bad example because we do that out of band, but anyhow. SourceFire, Palo Alto, Checkpoint, Fortinet, all the devices, Citrix, NetScaler, that are supported, that essentially those vendors have written, ASA, certainly not to exclude that, that the vendors have written to work with and published a device package, which includes an XML specification file and a Python file on how to interact with those devices for Cisco ACI. So the APIC is based on, as we mentioned, a hierarchical object model. So everything is represented as an object, and every object can be manipulated via REST. Keep in mind that there are going to be a handful of objects that you deal with regularly, like bridge domains, subnets, VRF or private network. We also call that a context, contracts, EPGs, application profiles, and even maybe some of the fabric access policies, VLAN pools, VXLAN pools, physical domains, VMM domains, layer 3 routed domains, interfaces, interface selectors, all of those things. But even kind of the quick, not even close to exhaustive list I just rattled off, that doesn't even begin to come close to all the managed objects there are. And every one of them can be manipulated via REST and has a representation in the managed object model and in some form of URL or sub-body component. So we have over 5,000 objects in the management information model, okay, in Cisco ACI. So do keep in mind that, like I said, there'll be a lot that we work with pretty regularly, but it is nowhere near what you could do in terms of really you can do anything. And anytime, it's actually a very important thing to note, anytime you're, let's just say, using the web interface to Cisco ACI, so you get into the web UI for APIC, or the GUI, if you want to call it that, when you get in there and you make any change, it is not directly configuring the APIC controller or the switches or anything else. That web interface is actually calling the REST API. It's calling the REST API. If you've worked with Cisco UCS, Unified Computing System, at all, especially the B series, I guess it could also control the C series as well, and does in many cases, but UCS Manager, whenever you got in through the old Java interface or the new HTML5 interface, you didn't configure the Fabric interconnects. You configured, or really you interfaced with, at the time, the XML API that then programmed the rest of the hardware for you. Same thing is true with ACI. When you get in through the web user interface, you're actually telling the web page what to do, and it's making a REST API call to the back end, which is doing the configuration. So that's important to note, and that's why we can use the API inspector that we'll take a look at here in a moment, and that will show us every single thing that we're doing from a web user interface perspective and how we could then use or consume that in a standalone program or a application that we're writing. So again, we do have support for post, get, and delete. We have from an HTTP perspective, or HTTP method. We have support for JSON or XML for serial data. We also do support event-driven notifications. So we can subscribe to certain things, and we have to know how to open a WebSocket. But once we open a WebSocket and we subscribe, we will essentially, once something changes, so let's say we subscribe to an interface and it goes down, something will be pushed from the APIC back to us, letting us know, hey, this ACI pod or fabric, pod 1 leaf or node, 105, which is node, switch leaf 5. So pod 1 / 105 / 1 / 47. Okay, so ACI fabric 1, leaf 5, and then port 1 / 47 went down. Okay, and that would be pushed to us. So we can subscribe to event-driven notifications. So again, we start out, and we're just going to break down a URI, because this is a very important thing. I want to actually take a little bit of time to talk about how this is formatted, because this will really drive your understanding of how to use the RESTful API, specifically with Cisco ACI, and how to make sure that your calls are going to work every time. So we start with the protocol. Are we using HTTP or HTTPS? We're always going to use S, right? Good. Okay. ://. Then our IP address and our port. And then /API. We're always going to have /API. And then we're going to have /, and you won't have this curly brace, you won't have the pipe. This is basically nomenclature to let you know you're either going to use /mo or /class. One of the two, but not both, and not that whole curly brace pipe thing. Okay, so you're going to use /mo if what you're calling is the distinguished name, or at least the relative name of a particular, and typically the distinguished name of a particular managed object. Okay, so then, and actually it is the fully distinguished name. So then we're going to have /dn. If we had done /mo, we're not going to have /dn. So this actually is /mo. This is / and then whatever the dn is. Okay, so the actual distinguished name. So maybe I'm looking at maybe maybe I'm looking at tenant 1. So my DN would be /uni for the universe or the top level root, /TN dash, and then whatever I had called my tenant name. Okay? So I'll give you an example of this in a moment. And then it would be dot, either XML or .json. And this just depended on, let's say I was doing an HTTP GET, and I wanted to find out what the tenant looked like, and I would probably have some other query options here at the end, which is optional. But I would, I want to decide, or I want to tell the program that's making the HTTP call, do I want the information returned in XML format, or do I want it returned in JSON? And it's that simple. If I switch it to .xml, it will return XML. If I switch it to .json, the exact same thing, HTTP, APIC IP address, /API/MO, /the DN, which is /uni, /TN dash, and the tenant name, .json, it will now return that to me in JSON or JavaScript object notation serial data format. Okay, so likewise, I could do /class, and then I could say / and what the class name is. So maybe I want to return information on all the bridge domains in my network. Okay, and actually, let me just see. Maybe I can just bring this up real quick. So let me give you an example here. I'll just bring over a text pad, and we'll just say, here's my call. I want to do HTTP, and I want to call, let's make this a little easier to read here. I want to do HTTPS, of course, / my APIC IP, so 10. Let's say 29.104.24, and I'm going to say /API, and then I'm going to say /MO, which is my managed object, or calling a particular managed object, and then this is going to be what the DN would be. So the DN is going to actually be, so the DN down here, sorry, not SN, DN is going to be, it's going to be /, or let's just say uni, /TN dash, tenant, and let's just call it production. Okay, so that's my DN. That's my tenant production. So I'm going to take and put that in as uni /TN dash production. Okay, that's my distinguished name. And then do I want that information returned in XML? Put .xml. Do I want it returned in JSON? Put JSON. Okay, now to contrast that, maybe I don't want a managed object. Instead, actually, let's just leave that up there as an example. Okay, instead, I'm just going to copy this whole thing and say, instead, my class is I want to find out about the class for all tenants, which would be, I believe it's FVTN. Okay, I definitely know that like bridge domains, which I started to do, is FVBD. So let's just use that. So now I'm still going to have HTTPS, my IP address /API, but now I'm going to say class because I want to call information about a particular class. And the class is FVBD. So I want to learn about all the functional values for bridge domains in my entire ACI fabric. Not just within one tenant, but the entire ACI fabric, all tenants. Okay, so then I just say .xml or .json. And now I'm going to return all the bridge domains. And I can't remember if tenant is TN. I'm pretty sure it's TN, like that. So if I wanted to learn of the tenants, I would do, for instance, like that. And that would return all of my tenants. So let's just leave it here. So I'll include this with the files. So there's where my class equals, and there's where my distinguished name equals. Okay, so one is a managed object. I'm calling a particular DN, or distinguished name, and one is an entire class, and I'm calling a class of objects. Now, likewise, this could have been a get, where I'm getting information or learning, or it could have been a post, in which case this would also have to have the body And typically it's actually well, if we were doing a post, we couldn't do it across a class. A post we do to a particular object, which is a DN. So here we could do get or post. Here we could do get for our class. And we also then have at the end this option. So we can say question, and then we can add options. So we can have essentially our query parameters and what those query parameters equal. And we'll take a look at how to format those query parameters, or specifically how we can tell ACI to show us what those are really easily. There's a number of good network programmability resources. There are lots of free scripts out there on GitHub/data center, which is Cisco's handle on GitHub for ACI and Nexus 9K and 3K. There is the full APIC programming guide and all the class information, all the managed information model. And you can even leverage free online learning resources for learning, Codecademy, Coursera. There's obviously paid for courses like Pluralsight and Lynda, and of course the one that you're on right now for learning. And some of those have really good generic or general RESTful API and Python programming. And then there are some that are network specific and even Cisco ACI specific and Nexus 9K standalone specific, like the one you're on. So do definitely take a look and use all available resources. Don't just use us, use everyone. So practice, we definitely think, and I mentioned this at the beginning, the best way that you're going to learn any sort of programming, even just basic scripting or basic RESTful API information and how to interact with it, is to find some task that you can use on a daily basis. Okay? So create something, come up with a use case, use the ACI simulator if you have access to that. If not, use dcloud.cisco.com. That's free. And if you're a partner, you should be able to have access to the ACI simulator. And anyway, you can do the full RESTful API against dcloud, which is using the ACI simulator, or if you have it on your own local laptop or locally installed somewhere in the cloud, something like that, or at your data center at your company. Or if you have an APIC controller and you have a real one, you can obviously run it in production, and then you can test the data plane as well. Find something, run these RESTful API commands through the various tools we're going to talk about, like Postman or using Python or Java or Ruby or whatever, and figure out, kind of play with it, start with the basics, and then do these things regularly. But I will definitely tell you, if you don't use it, you lose it. So you will forget about how what you've learned works if you don't use it on a regular basis. So let's discuss the ACI toolkit now. So the ACI toolkit is it's a simple toolkit built on top of the APIC. And this essentially is a simple set of Python classes and modules that you can import the entire ACI toolkit, or you can import, typically you would import some particular subsections of it so that you could just use those subsections. It does not have full functionality. Okay? So this is not meant to give you 100% access to the APIC. If you want 100% access to the APIC, learn the Python native SDK or use the RESTful API directly and make your configurations that way. But I will tell you, the native Python SDK, especially if you're not a programmer by trade, can be a little daunting, and it has a lot of information. It's fairly complex to use, but then again, it is extremely powerful as well, because it does have access to everything. So the idea is, if you know what you're doing, or you need access to something that the ACI toolkit does not give you, then you want to use the native Python SDK. The idea with the toolkit is it's another level of abstraction. And with that level of abstraction comes a simplification. So you have a few things. You have, first of all, there's a few pre-built applications that already run on the ACI toolkit. And the ACI toolkit is, it's something that is, depending on the version of ACI APIC code that you're working with, or that you have in a simulator or in a real test, lab, or even production environment, you may not see the ACI toolkit natively on the box. So in later versions of code, it's something that's natively on the APIC, and you can just call it right from there, which is fantastic. No additional VM to load and stand up. But if you're running with older versions, 1.0 ACI code, 1.1 ACI code, then you're going to need to have a separate virtual machine running Linux and running the ACI toolkit that you've downloaded, installed, and of course first you would have had to put in all the necessary dependencies. And from there you can either use the built-in applications, and there's like 4 or 5, or, which is great if you just want to run those prepackaged applications as apps, web apps, or you can use it as the import, right? So you can import it into another Python program and use simplified commands that give you the ability to do and preserve and use the basic concepts like tenant creation, deletion, and changing, EPGs, contracts, exposing ACI to a DevOps as a library or code. This is a really good way to get started. So here's an example. So this is a Python script where we essentially, we're seeing that from the ACI toolkit, which had already had to be installed, but from that Python module, we're importing everything. We could also just say import ACI toolkit. That would work as well. And then it actually would do something a little bit different in the way that we used it in the code, so this is actually a little bit nicer. Anyhow, so from there, we could create 2 EPGs within the same context, or private network, or VRF, all the same word there, and have one EPG provide a contract to the other EPG. So the hash, well, first of all, these triple quotes, this is just a multi-line comment. So this isn't code, it's just a comment. And then the hash, also a comment, but just on a single line. So here we're using comments just to say what the script is doing, another single line comment just to say we're about to create the tenant. And here we actually have the code, which is the variable called tenant, something we just created, equals, and now this is coming from the ACI toolkit. So we're saying, calling, in case sensitive, we're calling tenant, and then parenthesis, and the value that we want to pass in to create the tenant. And that's a string, so we have a single or double quote, and we have ACI-toolkit-demo. And once, now this doesn't immediately create the tenant, it actually packs all of that information about this particular class and method for tenant and the name, the value for that, in this variable called tenant. Okay, so then we comment that we're about to create an application profile, and we pack the app profile with the name, which is, or the string, my demo app, comma, and then there's no string around this, so this is actually calling this variable tenant. So we're about to put this application profile, or application network profile, if you want to call it that, into this tenant, which is really this, which was the creation of this tenant. So the tenant would be created, and then the app profile would be created inside that tenant. And then within the app profile, which is packed into this variable called app, so within that, we're passing that as an argument to this function, and this function is EPG, the name of the EPG, and the app we're passing it into. And then, so we're creating a web front end and a database back end. And we are packing the web front end into a variable called web EPG, and the database backend into a variable called DB_EPG. Okay? We need to make sure that we have a VRF, or a context, or a private network, call it whatever you want, and a bridge domain, which is our VXLAN. So we say context, that's the variable name, equals, and we basically create the context, here's the name, in this tenant, which is this tenant. Then we create the bridge domain using, we're packing it into a variable called BD. The Python call, or Python class, Python function from ACI toolkit is bridge domain. Here's the value, BD-1, and we're packing it, or putting it, into this tenant. Then we do something called BD dot. Now this was our variable name, and we're saying dot, and we're saying add context. Now this, first of all, the BD is something we defined. Dot means we're using an extension to the bridge domain portion class, and we're adding a context, and this is part of the ACI toolkit, and here is context, so we're actually adding to the bridge domain our VRF. Then we add to our web EPG, we add BD, which is again another ACI toolkit function, and we add BD, which is the bridge domain, and we also put the database EPG in that same bridge domain. Now, we had also imported credentials, and the script goes on, and I don't have the whole script here on the screen, but this was just to give you an example of, and if this seemed complex, I can understand that, especially if you're just beginning. Check out our other course. But this is I can tell you, very, very simple compared to what you would have to do if you were making native Python calls against the APIC native SDK. Now keep in mind, we've been talking about two very different things. We've been talking about REST API access, and now what we're talking about here is native Python. They're two different things. One thing is a programming language using the native SDK to do things in the APIC. The other is a model and a way of making calls through HTTP to create things in the APIC. They're both accomplishing the same values or objectives, but they're using two very different ways or methods. Now, we also can kind of combine the two. So I could use Python as the programming language to call REST. That's not what we're doing here, just to be clear. And many of you already know this, and that's fine. You're saying, yeah, I don't need you to explain that to me, Mark. It's not for you. It's for everyone else that may not understand these differences. So if you're very new to programming, we are here using a programming language called Python to do native calls, but instead of, again, and I'm just going to go back here real quick, instead of native directly, instead of our Python program kind of sitting over here and doing a call directly to the APIC, instead we're making this call to the ACI toolkit, or we're using the toolkit. We're still making the call to the APIC, but we're using the toolkit as an abstraction, a way to simplify and write this code in a much easier way so that we don't have to learn all of the kind of framework and constructs of the native SDK. So the ACI toolkit also has, like I said, built-in applications. And again, if you're running APIC 1.2 or later, then you actually have built in the native ACI toolkit, specifically the CLI, okay, the simple CLI. So I can simply do a config T or a show interface, and I can see everything on my entire fabric. If I have 200 leafs, I can see all of them through a show interface. It'll show me all of them. It'll show me, first of all, fabric number, so pod 1 or fabric 1, and then leaf 101, which is really my first leaf, and then on down, interface 133 through 43, and it would keep on going down, leaf 102, 103, 104, up to leaf however many I have, okay, in a single command line. And I can interact with this. Now, I can't do everything through this command line. I can config T, I can create tenants and bridge domains and subnets and contracts. I cannot do everything. I can't create L4 through 7 service graphs. I can't create fabric access policies. So there is still a lot that I would either have to use the web user interface or native REST API or native Python to do, but this does give me a command line for most traditional tasks. And so some examples are, I can do switch to tenant, just like I would switch to, in an ASA, I'd switch to another context. Or actually, this is, really more akin to almost switching to a VDC in an Nexus 7K, and then switch back. And then within a particular tenant, I could go into config T and create a context or delete the context and, tell allow all, which is basically to say policy is unenforced, or no allow all, policy is enforced. Could do things like create a bridge domain or delete the bridge domain. I could do things like I already said, create the context, delete the context, and within the bridge domain, here, this is once I create the bridge domain, then I'm associating the context to this bridge domain, and then I'm giving a subnet, which is really creating the SPI. So there's some built-in applications I mentioned, the ACI endpoint tracker, ACI lint, cable plan, ACI diagram generator, snapback. There's also one called Intersight now. And actually, a lot of these are being built into code. So if you're running 1.2 or later of the ACI APIC controller fabric code, then some of these are already built in. So for instance, snapback and multi-site. So using the APIC APIs, we do use Python 2.7. You do have to run a few things, and actually one of the labs that we have that you'll see here very shortly does actually walk you through literally everything you need to do. This is a very simple, high level of what you need to do, and this is pretty much the mandatory basics of what you need to do to get this up and running. But there are a lot of other things that you may and probably will want to use, and our lab takes you through creating your entire, standing up a very basic Linux Ubuntu server, and then taking it through to a very kind of deep level of adding all the developer tools that you might need. So we've actually already talked about this, the REST API overview, so I'm not going to go into this again. It's kind of a duplicate slide, but here is what I mentioned earlier from the ACI web interface. And up at the top right, you always have the ability with your welcome and your username to click down and choose Show API Inspector. And from there, anything you do in the web interface will automatically generate all of the all of the REST information. And you can search within there. So let's say I want to only see what I'm doing to create something, but I don't want to see all of the kind of noise, which is all of the HTTP GETs that are occurring from every single web-based call that's populating the web page with all the information I need. So I could search for post, all caps, post. If I want, I can match case. And then what would happen is if a post was found, it actually pops up another kind of line in between search and options. And I have a tag or a tick box called filter. And if I tick that box called filter, it will filter out all the noise except for where a post is found, which is where my, in all caps, match case, my HTTP post is going to be used. And then I can just copy and paste. And again, our labs are going to take you through how to do every single thing there, how to create Excel spreadsheets and use those to generate CSV files with all of your data, and to run those through Postman through hundreds and hundreds and hundreds of different or the same type thing being created hundreds of times. So how to create, let's say, 250 EPGs and 250 bridge domains and 250 subnets, one-to-one-to-one mapping, and essentially grab a few lines, I think 5 separate HTTP post commands from the API inspector. And after you've run those or gathered those 5 commands through the API inspector, take and modify those to use variable names, and then run that through the tool called Postman using the CSV file that you had exported from Google Sheets, or if you can get Microsoft Excel not to throw in all the garbage characters, use that, whatever. And then from there, run those 5 HTTP post API captured or API inspector captured REST API commands against hundreds and hundreds of lines, potentially thousands of lines, whatever you really want, of your actual variable names or the actual values you want in there. So we'll go through that in the lab. This is an incredibly powerful tool. One of the other things I want to show you while we're here is there's something called Show Debug Info, and this will show you at the very bottom of the screen the DN, the distinguished name, or actually both, and the class of the managed information model that you're on. And this will be very helpful a little bit later. So with ACI, we have this application connectivity awareness. We have this visibility into the application as it pertains to the fabric, to the infrastructure. So this gives you really a true next generation of analytic capabilities. So for an application running for a customer, maybe like a pet store type application, I can see that what any triggered events or queries that have happened, so any hosts, hypervisors, or VMs that have shown up, or bare metal, any hypervisors that have gone away, any rebalance of clusters, and I can see how this application is performing. So for instance, I could see that the Pet Store development lifecycle iteration of this app called Pet Store Event is using Leaf 1 and 2 and Spine 1 and 3, and the atomic counters are showing that right now it's not terribly healthy, right? It's only got about 56% health. But in QA and production, which use different types of leafs, and maybe they could even use the same leafs but different ports, or even the same leafs and the same ports but different VLANs. One of the VLANs is down, and that's why dev is not happy. Health score is pretty bad, kind of 56%, but production and QA are just fine. So looking at all of the specific things, whether it's a particular leaf or multiple leafs, a particular port, or even everything's using the same port but different VLANs, and one of those is causing a problem, it's blocking or something like that, we can see what the health score is related to the overall fabric, each individual leaf and spine switch. We can then see at a top level for an entire tenant a health score, per application within the tenant a health score, and then at kind of a even lower or more granular level per EPG. And all of this is queryable and actionable via the REST API and through the native Python SDK. So I can find out what this health score is and react or do something based on that.